Lesson 13.6, Circular Functions. We've been talking about the unit circle, and now we're going to talk about a different type of question, but still referring to the unit circle. And we talked about how on a unit circle, every coordinate on the unit circle is an ordered pair that has an x and a y, and the x and the y refer to cosine and sine. Now, because it's on the unit circle, we know that if I have the coordinate 1/2 √3/2, then we know that at that degree or that radian, or degree or radian, then we can easily say that the cosine of it is 1/2, and the sine of it is √3/2. So if I tell you that I have a coordinate that's on the unit circle, for example, here, point P is on the unit circle, and they ask us what is the sine and cosine of theta, then it is as easy as it seems. The first value is the cosine, and the second value is the sine. So at the point √7/4 and 3/4, cosine of theta is equal to √7/4. And sine of theta is equal to 3/4. Nothing hidden about it, nothing tricky, but the reason, the whole point that we can say this, the whole reason for it, is because it is on the unit circle. And that's what allows us to do this. I'm going to take a little bit of time here to look at a graph of sine and cosine, unlike what we've seen with the unit circle. And that is to make a y-axis that refers to real numbers, and an x-axis that refers to either degrees or radians. In this case, they are all degrees. We're going to graph, using the unit circle, we're going to graph what it looks like on an xy plane. Now, if we look at our unit circle, and we're talking about sine, then the sine of 0 is 0. At 90, I'm going to pick the big points here. At 90, sine is 1. At 180, sine is 0 again. 270, sine is -1. And at 360, it's 0 again. Now, this is not a graph of straight lines, so I'm going to curve this, and if I plotted every point, I know that it curves. So sine, as you go along the unit circle, increases in value up to 1, and then it starts to decrease again to be at 0, and then it becomes negative in the third and fourth quadrants, and then comes back to 0. Now, if I continued this on, we would start over. The pattern would start over. And this is what's called the period. So how far do you go before sine starts over? Here it goes up, then it comes back down, but then it goes negative, and then it comes back up, and then it starts over right here. So the period of sine is 360 degrees, or 2 pi. Again, I didn't write this on here, but if we wanted to talk about radians, this would be pi/2. This would be pi, 3 pi/2, and 2 pi. And that's the graph of sine. Cosine, similar, all right, looks like this. Cosine of 0 is 1. Then it's 0, and it's negative 1, and it's 0, and back up to 1. And it's not straight lines, it bends. And plateaus. So we ask the same question again. What is the period of cosine? Well, it goes from here, it crosses over, becomes negative, because cosine is negative in the third and fourth quadrants, and then back up to 0 here. So again, the period of cosine is also 360 degrees, or 2 pi, before it starts repeating. Again, if I continue this on, it would follow the same pattern. So it comes down to what we have already mentioned in the past. Trig is sinusoidal. It's cyclical. So 360 is when it starts to repeat itself. And 690 is just the showing or the example of you going around the circle to 360 and continuing on. Now, if you continue on all the way around, 690 is about there. In other words, if I want to get it into my unit circle realm, I take 690 and I take away 360 and see what we get. And that would be 330. Now 360 is a full circle, so 330 is something I have on my unit circle. And the cosine of 330 is root 3 over 2. So even though it's way beyond 360, I can bring it back to see where make it easier to look at and see where it fits on the unit circle. 405 is the same way. If I subtract 360 from it, it will take it right back to where it was, but with smaller numbers, and that's 45. And the sine of 45 is root 2 over 2. Now, cosine of negative 3 pi over 4 is a negative rotation, okay, to there. So it's a negative rotation, but again on my unit circle, that would refer to 5 pi over 4. If I look at the unit circle, 5 pi over 4 for cosine is negative root 2 over 2. Same with negative 2 pi over 3. That will take you to here. If you look at that the other way, that would be the same as 4 pi over 3. And the sine of 4 pi over 3? Negative root 3 over 2. So it just shows us that even though you go beyond 360 or beyond 2 pi, or even go negative rotation, so you're not even from 0 to 360, you're at like negative 90 or negative 150, you can still find its equivalent place on the unit circle. And this then is exemplary of the cyclical part of trig, or that it has periods and then it starts to repeat itself after 360 and 2 pi. And this ends lesson 13.6.